Welcome to the deep dive.
Ah,
Ready to dive into some tech history today?
always.
We're going to be exploring UNIX System V.
Ah, yeah.
Got some excerpts from the Wikipedia article here.
Okay.
And I think it's going to be really interesting to see how this system, even though you don't really see it that often, like on your desktop computer,
Right.
it's still relevant, even today.
Yeah, it's kind of like the ancient Roman aqueducts.
Okay.
They're still supporting modern infrastructure, even though they've been around for centuries.
I like that, yeah.
System V is kind of like that for the digital world.
So for people who might not know, like, what exactly was UNIX System V?
Well, imagine a time before Windows or Mac OS.
Okay.
Back in 1983, AT&T released System V.
Okay.
It was one of the first commercially available Unix operating systems.
Mm.
And this wasn't just any Unix. It was standardized. It was business-minded.
Yeah.
A real contract to that, like more academic, free-flowing BSD Unix.
So almost like the corporate world versus like the hackers in their dorm rooms kind of thing.
Yeah, precisely. And just like any tech, System V went through an evolution. Several major releases, from SVR1 to SVR5, building on each other.
So I'm guessing this is where we start to see some of the features that we still use today.
Absolutely.
Okay.
So SVR1, released in 1983, was the successor to System 3. It introduced the Vi editor,
Oh, yeah, I've heard of that.
still a favorite among programmers today.
Mm,
It also had performance enhancements that made things faster and smoother.
makes sense.
But perhaps the most important thing was inter-process communication,
Okay.
a way for different programs to talk to each other within a computer.
Kind of like networking, but just within one machine.
Exactly, like the precursor to networking, but all happening inside a single machine.
Wow.
And this was all on DEC mini-computers, the workhorses of the time.
Oh, wow. So way back then.
But SVR2 came along in 1984.
Okay.
That added features like shell functions, little mini programs you can build right in the command line.
Interesting.
Also introduced the SVI, which helped keep different System V versions compatible.
Compatibility. That was a big deal, right?
Huge, especially for businesses. They needed to know their software would work across systems.
Right. Makes sense.
And SVR2 brought demand paging,
Okay, what is that?
a memory management technique that drastically improved performance. It only loaded the parts of a program needed immediately, not the whole thing.
Okay. So much more efficient.
Exactly. It was a big step towards the multitasking we use today.
Interesting.
And SVR2 became the basis for Apple's AUX and ESCO Exenix.
Oh, wow. So starting to influence other players in the tech world already.
Yeah.
What about SVR3?
SVR3 in 1987 was all about connectivity.
Okay.
Introduced streams.
Streams.
Yeah. A framework for input and output made it easier to build network applications. We also got RFS, a way to share files between computers, and the TLI network API, tools for building networked applications.
So like the very beginnings of the ability to easily share files and connect computers.
Yes. They were mostly used within private networks back then, but these were the building blocks for what we now know as the Internet.
It's amazing to think about how all these things we take for granted today, have roots in these older systems.
It really is. But the real star was SVR4, released in 1988.
Right.
This wasn't just an update. This was a complete overhaul. They merged features from SVR3, BSD, Xenix, and SunOS.
Oh, wow. So they kind of took the best of everything.
Exactly. They took the best from the Unix world and put it into one release.
This is where the famous Unix unification comes in, right?
You got it. AT&T and Sun Microsystem, rivals at the time, decided to create a unified Unix.
Wow.
It was a big turning point. SVR4 brought us TC, PIP, and sockets.
Okay.
Those are the foundation of today's internet. It also had the UFS file system, support for multiple user groups, even the C shell from BSD. Gave users more choice and flexibility.
It's amazing to think about how much came from this collaboration. What about Sonos?
Well, Sonos contributed the virtual file system interface.
Okay.
It lets different types of file systems be accessed in a uniform way. This laid the groundwork for things like cloud storage.
Oh, wow. So that's where that comes from.
Yeah. SVR4 also got NFS from SunOS, the network file system.
NFS, I feel like I've heard of that.
That's because it's still widely used today to share files between computers on a network.
Oh, okay.
It also got a new virtual memory system, could run larger and more complex programs, and even the beginnings of a graphical user interface, Open Windows.
Wait, they had GUIs back then.
Yeah. Not like what we have today, but it was a big step forward.
So networking, file handling, a GUI.
Yeah.
What else did SVR4 have?
Well, it got x86 device drivers and binary compatibility from Xenix. Programs written for x86 PCs could run on System V without changes. This was huge for businesses.
Right, so they could use the same software on lots of different hardware.
Exactly. It also had the Corn Shell, a more powerful command line interpreter, better C compatibility, support for multiple languages, stronger internationalization support. Plus, they embraced standards like PO6 and XOpen to unify the Unix landscape.
So it really was like the Avengers of Unix.
Yeah.
Bringing together all these different features.
Right.
No wonder it was so influential.
Yeah.
But we're just getting started on this deep dive.
Right.
What happened after SVR4 took the world by storm? We'll pick up this story in the next part, so stay tuned. It's wild to think that most people today probably haven't directly used System V.
Yeah.
But it's like everywhere.
Oh, it's everywhere. Our modern digital world runs on those foundational systems.
It really does.
It's like, you don't see the foundation of a skyscraper after it's built, right?
Right.
But without it, the whole thing collapses.
Exactly, yeah. Okay, so going back to those Unix wars, that rivalry with BSD.
Oh, yeah.
Were there any specific moments or events that really, stick out in your mind?
I mean, it wasn't a literal war. Right. More like a clash of titans, Okay. Each one trying to dominate the Unix world.
Okay, so what were some of those, battlegrounds?
Well, networking was a big one. System V initially went with streams, which was this modular approach for handling input and output. Flexible, adaptable, sure, but also kind of complex. BSD, on the other hand, they were all about TCP/IP and sockets.
So one was complex, the other was more straightforward.
Exactly. Another big difference was just the whole philosophy,
Yeah.
System V coming from AT&T, they were all about that corporate top-down approach.
Okay.
Standardization, compatibility, they wanted a uniform platform, especially for businesses.
Right.
BSD from the academic world was much more open, collaborative. They wanted flexibility, innovation, always trying new stuff.
So two completely different cultures, basically.
Totally. Like buttoned up corporate versus the freewheeling academics.
Yeah, I can see that.
And you saw that in how they developed the systems, too.
Okay.
System V releases, very controlled, documented, all about stability.
Right.
BSD, much more open to outside developers, faster, more iterative.
Interesting how these cultural differences play out, even in tech.
Oh, totally.
Did those differences ever cause any, big blow-ups or arguments?
Oh, for sure. It got personal.
Right.
Oh, yeah. Big names in Unix like Ken Thompson, Dennis Ritchie, they had strong opinions.
Okay.
And those disagreements sometimes, spilled out into the public.
Wow. So it was like a family feud, but for, the future of computing.
Pretty much. But, like I said, things cooled down eventually.
Right.
Both sides kind of realized the bickering was holding them back.
Makes sense.
Users were getting frustrated. Developers were tired of writing the same software multiple times to support different platforms.
Yeah, that sounds like a nightmare.
It was. So it was a can't we all just get along kind of situation.
But how'd they actually bridge that gap?
Well, standardization efforts like POSX popped up. Okay.
They wanted common standards for Unix-like operating systems. That helped smooth out those rough edges between System V and BSD. So devs could write code that run on both.
So kind of like a universal translator?
Exactly. And then, of course, you have Linux coming onto the scene.
Oh, yeah.
Took inspiration from both System V and BSD.
Okay.
Took the best features from each, became this hybrid, stable like System V, flexible like BSD.
So almost like the peacemaker, ending the Unix wars.
I like that. And in the process, Linux inherited a lot from both.
Right.
So those innovations kept shaping computing for years to come.
Wow, what a story. Competition and collaboration driving innovation.
Yeah.
Okay, let's switch gears a bit. Talk about System V in the market.
Okay.
How did it get so big? And what caused its decline?
Well, its popularity was huge in the 80s and 90s. You could get it by 86 PCs from a ton of vendors. Businesses loved it.
Okay.
It seemed like it would become the standard.
But nothing lasts forever, especially in tech. What happened? Right. Well, as PCs exploded in the 90s, Linux and BSD started getting popular.
Okay.
They were free, which was a big deal.
Right.
People wanted alternatives to expensive proprietary operating systems.
Almost like indie music challenging the big record labels.
Exactly. And in music, open source forced the established players to adapt. Some did, like Sun Microsystems with Solaris.
Okay.
Others, not so much.
So openness and cost were huge.
Totally.
But you said earlier that even though System V isn't on PCs as much, it's still around in some ways.
Oh, absolutely.
Can you tell me more about that?
You don't really see System V on desktops, but it's still big in servers and high-performance computing.
Okay.
IBM's AIX, which runs many of the world's supercomputers,
Yeah.
direct descendant of System V.
Wow.
Same with HP's HPUX, big in enterprise servers.
So System V is kind of running things behind the
In
scenes.
a lot of ways, yeah.
What about Solaris? How does that fit in?
Solaris is interesting. It started as a collaboration between AT&T and Sun. It used the best parts of System V and BSD.
So it's like a hybrid, taking the best of both worlds.
Yeah, exactly. Solaris got big in servers and workstations, still used today by lots of organizations. And the really cool part is that Sun released Solaris's source code as Open Solaris.
Okay.
It was open source, so others could build on it. That led to Illumos, a community-driven project that's still developing the Solaris code base.
So even these old operating systems can get new life with open source.
Absolutely. But we've only just started talking about how System V impacted computing.
I know, right?
Next time, we'll explore how some of its key concepts ended up in Linux and BSD and talk about the influence of standards like PO6.
It really blows my mind, these like ancient systems still being relevant today. It's like, what if you found out the foundation of your house was built with like bricks from Roman ruins or something?
I like that.
Still working, still solid, but with this like whole hidden history.
And System V is like that too. It's hidden in all sorts of places. Remember, inter-process communication.
Yeah, that's how programs talk to each other on a single computer.
Right. That became so fundamental that it's pretty much standard in every modern operating system now.
Man.
Linux, BSD, Mac OS, even Windows, they've all got some System V DNA in there somewhere.
So even though we don't see System V itself that much anymore, its ideas are kind of like the underlying structure of how computers work.
Exactly. It's like the plumbing or electrical wiring in your house.
Okay.
You don't really think about it until it breaks, but it has to be there.
Right. Everything depends on it.
Same with these Core OS concepts. They're what makes everything in the digital world work.
Okay, so speaking of common ground, let's talk about PSXX.
Oh, yeah.
You mentioned that was important for, like, bringing order to the early Unix world.
Big time. Remember how all the different Unix versions were competing?
Yeah, and that caused so many problems.
Total compatibility nightmare for developers. PSX wanted to fix that? Okay.
They set up these common standards that all Unix-like operating systems could use. Meant that developers could finally write code that would run on different systems without any weird issues.
So PO6X was kind of like a universal translator for all the different types of Unix.
Exactly.
Did that have a big impact on how software was developed?
Oh, absolutely. Made it way easier to write what we call portable software, meaning it could run on a bunch of systems without having to change a lot of code.
That makes sense.
Huge for the software industry. Cut down development costs and meant you could sell to more people. And it helped developers work together and build on each other's work, too.
So PFEDX really was a game changer.
Definitely.
It's amazing how these, like, technical things can totally change the way technology evolves.
It's true.
Okay, before we wrap up, I'm curious about, like, the what-ifs with System V.
Okay.
What if SVR6, that big upgrade, had actually been released?
Yeah.
How do you think things might have been different? SVR6 was supposed to be a huge step forward. 64-bit support, all sorts of new features.
Okay.
Who knows? Maybe System V would have stayed on top in the server world for longer.
Yeah.
But it's also possible that Linux and open source were just too powerful a force.
Right. Things were changing fast.
Yeah.
So it's one of those big what-ifs of tech history.
For sure.
We'll never really know.
Right.
But even without SVR6, System V's impact is huge. Innovation, competition, adaptation.
Yeah, and even though you might not see it everywhere, it's still shaping things behind the scenes.
Absolutely.
It's been a fun trip through computing history.
I know. I've learned so much. And to everyone listening, we hope you've gained a new appreciation for UNIX System V. It's a story that's still being written in some ways.
Yeah.
So go explore and see what else you could discover.
Absolutely.
Thanks for joining us on The Deep Dive.